Okay, Mustafa, can you see the whiteboard?
Yeah, I can.
Okay, so we will start first here by the first part, which is the differentiation. So the differentiation here is going to be labeled by dy over dx, or you can just mention it to be f dash of x. It's going to be the first derivative. What does the derivative mean? So here, the derivative means here rate of a change. So let us take an example. How do we calculate the rate of a change? If we have y is equal to 7x squared, and another one, y is equal to x squared. Last time we shared the rule about the power.
Yes.
So we said that if we have y is equal to x power n, so y dash, do you remember? What did we do here at this part?
Yeah, I remember.
Yeah, tell me what's going to be the rule here, what I'm going to do with the n.
And you're gonna minus it by 1
And
and multiply the n with the number that is down.
yeah, so you mean that this one is going to be n x power n minus 1. So you subtract 1 from the power and you put the n down. Yeah?
Yes, exactly.
Okay, so let us do this one here. So this one here is going to be, how do we get dy by dx? So I'm going to put the 2 down, and then I'm going to put x, and then 2 minus 1. There's going to be 2, and then the x is going to be power 1. Is it clear?
It's clear, yes.
Now going to the second one. So this one, to get the f dash or dy by dx, if we have a number outside, just keep the number as it is and then work with the x's. Because we can change this one. Just let us make here this one to be x power 5, for example. So here in this case, I'm going to go again with the 5 down. I'm going to keep the x as it is. I'm going to subtract 1 from the power. Then I should multiply the 7 with the 5. So this one is going to be 35x power 4. Is it clear?
Clear.
Okay. Now going to here, if we have f of x to be, this one is going to be a polynomial. What does it mean by polynomial? Do you know what does it mean by polynomial?
Like no, can you tell me?
Okay, for the polynomial here, this means that we will have a function that is having a power, but this power here has to be a positive integer. Positive integer means positive whole number. If you have the power to be either negative or fraction or decimal, this one will not be labeled to be a polynomial. So the polynomial means that you have to look to the power. Look at this one here. This is the power 3. And this is the power of 1. So this one is a positive whole number. So this one will be considered to be a polynomial. Is it clear?
Clear.
And if you here set for the polynomial, how many terms for this polynomial? How many terms? We have here 2 terms, as we have this one is the first term, 3x power 3, and this one, the second term, which is negative 8x. So we have here 2 terms, 3x power 3 and negative 8x. And you can just see that the 3 and the 1 are whole number, as we said. So this one is going to be considered as a polynomial. And what about the degree? We said that the degree of the polynomial has to be here the highest power. What do you have as a highest power here?
3.
Yeah, so this means that this is going to be polynomial degree 3 with how many terms? 2 terms. Is it clear?
Clear, yes.
Now let us try to do here the derivative for this one. So there is a space here. So f dash of x, I'm going to leave the 3 as it is. I'm going to go with the 3 down. Then x will be power what?
Power of 2.
Yes, power 2. Then continue with the next one, minus 8. The power here is 1. And then x. This one is going to be 1 minus 1. So let us simplify this one here. 3 times 3 is going to be 9x squared. Then minus 8. 1 minus 1 is what, Mustafa?
0.
Yeah. So what is x power 0?
We don't write the x.
Why? Because x power 0 is equal to 1. Any number power 0 or any variable power 0 is equal to 1. Is it clear?
Clear, yes.
Okay. Now it's your turn. I'm going to give you now a question. So let us take this one to be y, which is equal to f of x is equal to 8x power 7 minus x minus 4. Is this one polynomial or not?
This one polynomial.
Yeah, why it's polynomial?
Because we have 8 and 1 and 4, which are whole numbers.
8, 1, and 4. I'm not looking about 8 and 1 and 4. I'm looking about the powers. The power here is a whole number 7. The power here is 1. And the power here, there is no x here, so there is no power here. The power here is 0. So this one is called polynomial. Is it clear?
Okay, yes, clear.
Yeah, polynomial. How many terms do we have? 1, 2, 3. How many terms?
3 terms.
So 3 terms. And what is the degree for this polynomial? What is the highest power that we have it here?
7.
Yeah, so this one is degree 7. Is it clear?
Yes.
Let us do this one here, f dash of x. I told you that this is going to be your turn. Try to do this in your notebook, then share with me the answer, please. I will give you 1 minute from now.
Yes, okay.
Okay.
Okay, finished.
Okay.
So here we do 8 times 7, x to the power of 6 minus 1.
Just wait. So this one is going to be 8. You go with the 7 down and x power what here in this case?
6.
Yes. And then moving to the next term, what should I do here?
Will be minus 1.
Yeah. You just do it quickly because, yeah, just here, this one is x power 1. So you get the 1 down and the x power 0 is going to be 1. Yeah, that's perfect. And what about the negative 4?
It doesn't have a power.
Yes. Yes, because the rule here that if you have f of x to be having a constant, C stand for a constant, okay? So whenever you have f of x to be equal to the constant, this means that f dash of x will be equal to 0, so there is no need to write this down. Yeah?
Okay.
Okay, tell me, how do we simplify this one? Should I leave it like this, or does it need more simplification here?
More simplification. So 8 times 7 will be 56 to the power x to the power of 6 minus 1.
Yeah, that's perfect. What about if I ask you, I need here the second derivative? So how do I get the second derivative, which labeled here d2y over dx squared? So how do we here get the second derivative? I'm going to do the same, exactly, but I'm work with this as going to be the start here. So I'm going to keep the 56 as it is. I'm going to go with the 6 down. Then I'm going to go with the x power what here? 6 minus 1 is going to be 5. And this one will be 0, as we said that the derivative of a constant number is going to be 0. Is it clear?
Clear.
Okay. So here,
It will be 336 to the power x to the power of 5.
yes, x to the power of 5. Also, you can get again the third derivative. So if we need to get the third derivative here, what's going to be? I'm going to do the same. So the third derivative here for this one is going to be 336 times what, Mustafa?
Times 5 x to the power of 4.
Yes. This one here times 5 x power 4. So this
it
one will,
1680 x to the power of 4.
yeah, x power 4. Is it clear now?
Clear, yes.
Okay. Now moving to another one. It's a little bit complicated here. What about if we have y is equal to, and I give you a bracket to be x plus 4, and then another bracket x plus 2, and it's asking you to get here the first derivative. How do we get the first derivative? What do you think? From where should I start here?
You will multiply x with x and x with 2.
You mean that you're going to expand the bracket?
Yes.
Okay, so rewrite this first before going to the derivative. We have to expand the bracket. So you said x times x times x is what?
X to the power of 2.
Yes, x to the power of 2. Continue. What's going to be next?
Plus 2x. We're going to multiply
Yes,
next by 2.
yes.
Plus again 4x
Brilliant. Continue.
plus 8.
Perfect. What should I do next?
Now you find the derivative.
No. First,
Hmm.
you have to collect the like terms. So you have 2x plus 4x. In this case, is going to be 6x.
6x.
Is it clear?
Clear.
Now the function is ready to be work with it now, and we can get the derivative. So here in this case, we need to get f dash of x. So is it polynomial or not?
It's polynomial.
Yeah, degree what?
Degree 2.
How many terms?
2 terms.
Three terms. This is the first term, this is the second term, and this is the third term. Is it
Oh,
clear?
clear. Okay.
Okay, now let us go to make the f dash here. How do we get the f dash here?
It's gonna be 2x because you're gonna put the 2 down minus the power by 1
Yes,
plus 6.
plus 6. What about the second derivative for this one, Mustafa?
Second derivative is only gonna be 2.
Yes, perfect, which is going to be a constant value, okay?
Okay.
What about if we have y is equal to root x plus 5x power 8? Let us rewrite this. How do we say root x? Root x here is going to be power what? X power what? Here in this case, this one is 1, and because it's square root, this one is 2. So this one can be written x power half. Is it clear?
Clear.
Let us take here something about the roots here. So what about if you have x and you have this one to be a and this one is going to be b? According to the rule here, I have to write inside over outside. So this one is going to be x power a over b. So here, if you have x and you have this one to be 5 and this one to be 4, Can you help me? How do I use this rule to write in the form of power? X power what?
X power of 5 over 4.
Yeah, inside over outside. Perfect. Let us take another one. If you have X and this one is 3, so here's going to be X power.
1 over 3.
Perfect. 1 over 3. If you have this one to be X here and you have this one to be 9, so this one is going to be X power what?
X 9 over 1.
No, 9 over 2. This number here is not written. It is the 2. It's the square root. Okay?
Okay.
The same exactly as you write X. X means X power what? Power 1. If you just write the root without any number outside, this means that's square root. So this number has to be 2. Is it clear?
Clear.
Okay. Now, let us rewrite this one up here. So this one is going to be the y is equal. This one is going to be, as we said, x power half plus 5x power 8. Is this polynomial or not?
This one polynomial.
No,
Oh, no, not polynomial.
no, this one is not polynomial.
Hmm.
Do you know why?
Because of the half is not a whole number.
Yes, thank you for mentioning this. Perfect. So we said as the condition to be a polynomial that the powers has to be positive whole number or positive integer. And this we have a half, so this one will not be accepted to be a polynomial, okay?
Okay.
Now this one is ready now to get the f dash of x. So how do we get f dash of x here?
So it will be half
Yes.
half x.
Hmm.
Let me calculate the to the power of minus half.
Yeah, so this one is going to be half minus 1 is going to be negative half. Continue plus what?
Plus 5 times 8
Which is going to be 40. X power.
power of 7.
Yes, perfect, brilliant. So this one will be x power 7. Is it clear?
Clear, yes.
Okay. Just a second.